10C measurement, page 36, example number 2. If I'm given a grain silo and I'd like to paint the surface area of this grain silo, I'm going to use my formulas, but I'm going to figure out which parts of the formulas I actually need. So if I look up the surface area formula for a cone, you will notice that I have pi r squared plus pi rs. If I look up the surface area formula of a cylinder, the bottom part of my grain silo, I get 2 pi r squared plus 2 pi rh. If the goal here is to paint the exterior, you will notice that on my cylinder, I'm not actually using up all the sides of the cylinder. I'm not going to paint up here, and I'm not going to paint the bottom. So I'm not going to paint the 2 circles. The part of the formula that refers to the 2 circles is the first half. You'll notice that because it actually says 2 pi r squared, and that's the area of circles. So if I am painting the grain silo, there is no top or bottom to the cylinder. I am not going to paint the 2 circles. So for the cylinder, I only need to do the calculations of 2 pi rh. Similarly with my cone, I'm not going to paint the bottom of the cone, so I don't want to include the circle that's on the bottom, meaning that I don't want to include this part of the formula. Pi r squared is the circle part of the formula. I only want to paint the outside of the cylinder and the roof part of the cone. So now I have the surface area of the cone that I'm going to paint is just pi rs. So pi times a radius of 4. Notice they gave me a diameter of 8, so that means my radius is 4, and the slant height was 4.5 meters. For the bottom half for my cylinder, I have 2 pi times the radius times the height of the cylinder. Make sure I'm paying attention to each part here. So when I do these for the surface area of the cone, I have pi times 4 times 4.5. So I'm going to end up with 56.54867776. Sorry, there's 2 6's in there. And I'm not going to round until the end. 66776. And for my cylinder, when I type in 2 pi and multiply that with 4 and 12, I end up with 301.5928947. This is a composite shape, so I'm going to add these 2 areas together, and I end up with 358.1415625, so just 0.1. I'm going to include my units, meters squared, since this is surface area. For Math 10C, page 49, example 2, when I'm doing the volume of composite objects, I don't have the same worries as surface area because it's not like there's a side that I'm not painting. Instead, I'm making these gnomes out of concrete. So in terms of filling, it doesn't matter which side is covered up by another shape. So simply, I am going to take this cone, this half of a sphere, so I'll have a calculation to do where I need to divide my sphere formula by 2, and this cylinder, and simply combine these volumes. Eventually I need to find the concrete for 20 gnomes, so I have to take this total and multiply it by 20, but in general, if I'm just doing a composite formula, all I have to do here is find the volume of the cone, half of the sphere, and then the cylinder. So starting with the cone formula, I'm going to have the volume of the cone as 1/3 pi r squared h, and the volume of the sphere, remember it's half of a sphere, so this 4/3 pi r cubed, I'm going to take half of that once I do that calculation. And then the volume of my cylinder is pi r squared h. Once I do the calculations for these, all I'm going to do is add these volumes together to figure out the total volume of the entire composite object. So So my cone, once I do my substitution, 1/3 pi times 2 inches squared times by the height of the cone. And actually, I'm just going to leave this squared inside the brackets for simplicity's sake. I end up with a volume, my cone's volume, at 25.13274,123. Notice I'm not going to round till the end. My sphere, once I substitute in pi, and then my radius of my sphere is the same as my cone. So that's 2 cubed, which gives me 33.51032,164. But I'm going to take that number and I'm going to divide by 2. Remember, the reason that I'm doing this is because I have half of a sphere. So I actually end up, the volume of my half sphere is 16.755 and so on. Let's just move this cylinder formula down a little bit here. There we go. Make sure we get, oh, I'm not going to have the top part of my pie. That's okay. There we go. So my sphere was 33.51032,164. Remember why I'm dividing it by 2, because that's only half of a sphere. So the volume there is 16.75516,082. And for my cylinder, pi r squared h, I end up with, once I've substituted in, the radius of the bottom is different, so watch out for that, 3.5 squared, and a height of 7, that's different. I end up with 269.39157. So in order to calculate composite volume, you'll notice that I did not have to worry about any surfaces that might not be showing on the outside, because this isn't like painting the outside of something, this is like filling something up. So that's why we tend to think that composite volume is easier to do. So once I've added all these numbers up together, 269.39157 plus 16.75516,082, and my 25.13274,123. I'm using the entire long numbers because I don't want to round until the very end. Right? You'll notice that that means that my final answer to the nearest tenth is 311.3, and this is in inches cubed because I'm doing volume. If I wanted to actually answer the question, remember it's 20 ohms, so my final answer would multiply this number by 20.